So we've now identified 6 out of the 9 cells within our table. We found the easy ones. We found roots in vertex form, which took a little bit of work. What's going to pan out happening here is that filling in the last 2 cells associated with standard form are going to be the ones that require the most work. So the last cell that we're going to look at before we go do those is identifying how do we find the vertex if we're in factored form. This is something that we've talked about briefly but haven't formally stated in class, so let's go ahead and take a look at an example now. Again, what we're interested in identifying here is if we're in factored form, can we identify where the vertex location is on a graph? The reason why this is a little bit tough is because factored form is built to tell us about roots. It's not built to tell us about the vertex. That's what vertex form is for. What I don't think that I want to do here is first FOIL this out, then complete the square so that I can identify my vertex location. That sounds like a bunch of work, and I'm trying to avoid doing that. What I think is something that's a little bit easier to do is to stop and say, what information can I get easily, and how does that help me find the vertex easily? I don't want to do a bunch of work here. So even though our goal is to find the vertex, my first thought here is, since I'm in factored form, I think it's really easy for me to identify where are the roots located. In this example here, we can see that the roots are located at 6 and at 10. I'm going to go one step further with this, and I'm also going to suggest that we have an essential idea as to what this graph looks like here. I know that this parabola is going to experience roots at 6 and 10. I also know that this parabola has a positive a value, so I expect this parabola to open upwards. So here is my approximate graph of a parabola that opens up and has roots at 6 and at 10. What we'd like to do is use this piece of root information to help us identify some vertex information. One of the very nice properties about quadratics, and we don't get this with any other family of functions except for quadratics, is that quadratics always have left-right symmetry. There's always going to be this line of symmetry that exists down the middle, vertically, of any parabola that we can draw. The reason why this is really helpful for us right now is because what we can see is that where the vertex is located will always be on this line of symmetry. It's always going to be exactly halfway between the 2 roots. Here, since I can see that the roots are at 6 and 10, I then know that the x value of the vertex has to be halfway between 6 and 10, which we can see as 8. If I'm interested in also identifying, we've seen here that that is at the x value of 8. What I'm further interested in knowing is what is the y value associated with this point. Well, since I know the x value of the vertex, that it's 8, I can go ahead and plug in that x value into my original equation and identify the y value that's associated with it. By plugging in the x value of the vertex into my original equation as an x value, I have found the y value of the vertex to be -4. So I am now confident in stating that the location of the vertex here is at 8, -4. Let's just look at one more example. In this example, I picked some nice easy numbers so that it was easy for us to identify what number was halfway in between. Let's stop and think a little bit more carefully, mathematically, about how do we determine what number is halfway in between any 2 numbers. This next example looks very, very, very similar to our first example. We're still in factored form. We're still interested in finding the vertex. We still have all integer numbers that are associated with our equation here. So let's go about this in the same process, but realize that we need to be a little bit more careful and we just say halfway between. We would like more of a computation for that. So the first thing I'm going to do, and again, we're looking for the vertex, but the easy information for me is where are the roots. The roots here are located at -7, +4. And as I've said, it's slightly less comfortable for us to answer the question, what number is halfway between -7 and +4? Not only is this uncomfortable because we have one positive and one negative, but we also have one even and one odd number here. It's a little bit weirder for me to think about what number is going to be halfway between. Conveniently for us, we can determine what number is halfway between any two numbers by finding the average. You should think to yourself, for example, if you get a 70% on the first test of the semester and a 90% on the second test of the semester, then your test average overall should be 80. And 80 is what lives halfway between 70 and 90. So what I can do here is I can take the average of my two roots. That should give me the number that is halfway between. That will be the x value location of our vertex. In this case, the x value of our vertex should be at the average of -7 and +4. So I will add together -7 and 4. And since I'm adding up two numbers, I will divide by 2. This is how we take an average. Add up n objects and divide by n. In this case, it looks to me like we're going to get -3 divided by 2 as the x value of our vertex. Again, if we wanted to compute the y value of the vertex, we could go ahead and plug the x value that we found back into our original equation here. So the y value of the vertex should be then located at, I've got -3/2 plus 7, -3/2 minus 4. If we do a little bit of fraction computation here, we're going to find that this is going to be -3 times, I think of this as 1.5. So maybe this is 5 halves, or 5.5 that is remaining here, also known as 11 halves. Alternatively, you can think of 7 as 14 over 2. 14 over 2 minus 3 over 2 gives us 11 over 2. Similarly over here, I'll think of 4 as 8 over 2, -3 over 2, and -8 over 2 is going to give me -11 over 2. You should notice that this is the second time in a row that we've seen this outcome from finding a y value of a vertex, where both of these terms are the exact same term, they're just differing by a negative. This is something that you should always expect to happen whenever you're finding the y value of the vertex in factored form. Finally, we can complete this guy with a little bit of multiplication here. It looks like we have 11 times 11 for our numerator, which is 121. It looks like we have 4 for our denominator, and it looks like we're also multiplying this additionally by 3. And also I'm noticing here we have two negatives that are being multiplied together. These guys are going to cancel. So it looks like we're landing at 363 divided by 4 for the y value of our vertex here. So here I might state that our vertex, our HK location associated with this parabola, is going to be at -3/2. 363 over 4 appear to be the location of the vertex of this guy in factored form. By the way, just pay a little bit of attention. Sometimes I will only ask you for the x value of the vertex, and you should notice that getting the x value of the vertex was the easier of the two parts here. In this case, finding the y value of the vertex was a little bit obnoxious. It was maybe obnoxious to do, but the concept is still easy. If you have a known x value and you want its associated y value, just plug in x. That's how we solve for y. Concept is easy. Dealing with those fractions, a little bit annoying, certainly, but at least we now have a number that we can verify for the vertex location. I would encourage you to go to Desmos, throw this guy in as a graph into Desmos, see that you do get out the decimal version of both of those two values when you go to find the vertex location when in factored form. So now we've taken a look at locating the vertex location when we are in factored form. And I do like the concept that's associated with this one. We always want to remember that the reason that we like factored form is because it tells the roots, not necessarily the vertex location. However, one of the very convenient pieces of information we get about all parabolas is that they all share left-right symmetry. Therefore, if we can ever determine where the roots are located, the vertex location must be exactly halfway between. The way that we can compute where is halfway between any two numbers, any two locations, is by averaging those two numbers. So I'll go ahead and say here that the x value of the vertex is always going to be located at the average of the two roots. Here I'm using r and s to reference my two root values. Adding them and dividing by 2 will find their average. This will give us the x value of the vertex. If we are interested also in the y value of the vertex, we simply have to plug this x value back into our equation to evaluate the y value that we're going to get out on the other side over here. So now we've looked at finding the location of the vertex in a few factored form examples. You should now stop and do some practice on your own. Here are 3 quadratics that are each in factored form. You should find the x, y location of the vertex for each of the 3 examples. The first should be pretty easy. The second, you should stop and have to do at least a little bit of computation to find the x value of your vertex. The third one is going to be a little bit more difficult. You're going to have some fraction inconvenience to deal with, but I'm confident that all of you are able to add and subtract fractions, so I think you're going to make it just fine. For each of these examples, once you have completed the example, you should graph the equation in Desmos, and then you should see if the vertex of the parabola that you see in Desmos is the same as the vertex that you have computed by hand from each of these factored form quadratics.